Hello, my name is Mr. Summa and I expect I'll be doing most of your homework videos for this year. So, today there are going to be two topics we're talking about, combining like terms and the distributive property. For each of these topics we're going to have two learning objectives. The first learning objective, dealing with both of them, is that you can combine like terms and you can apply the distributive property in algebra class. What I mean by that is when we give you a problem set, you're able to go through and use these two skills. The second objective is that you can use combining like terms and the distributive property properly in a mathematical conversation. So once you complete the problem set, we want you to be able to talk about what you did with the people around you using these words. In order to set up talking about combining like terms, I'd like to talk about this scenario. So, when at a drive-thru, my wife wants 2 cheeseburgers and a large fries. I want an order of jalapeno poppers and a large fries. What do I ask the attendant for? Well, the things my wife wants are 2 cheeseburgers, which I will call 2C, and she wants a large fries, plus 1F. That is what my wife wants. I want an order of jalapeno poppers. I will call that 1J, because it is one order of jalapeno poppers, and a large fries, so plus 1F. Those are all the things we're asking the attendant for. But when I order, I don't have to tell her I want 2 cheeseburgers and a large fry, and a jalapeno poppers and a large fry. I could simply put these things together because they are the same and ask the attendant for 2 cheeseburgers, 2 large fries, and 1 jalapeno popper. But I don't have to tell her I want 1 jalapeno popper. I can just say I want 2 cheeseburgers, 2 large fries, and jalapeno poppers. And she will automatically assume, or he, that I'm asking for 1 order of jalapeno poppers. What we've done here is actually combined these like terms, because they're the same thing. They're both fries. Put them together. In here, I'm going to look for similar things. I could call X's hamburgers and call numbers something else, or I could just move on to math. In this first one, we'll give labels to them, and in the second one, we'll just combine things that are similar. So up here, I'm going to say, there's some X's and there's some X's. In order to not get messed up, I will call X is hamburgers. I also have these numbers. Neither of them have X's, which tells us they are different than the X's. So, numbers there, numbers here. I'm going to call numbers fries. So, in total in this problem, how many hamburgers did I want? Well, I wanted 3 hamburgers here and 4 more hamburgers here for a total of 7 hamburgers, because X is our hamburgers. How many fries did I want? Well, I had 10 fries, and then I want to take away 3 of those fries, for this -3. So, 10 minus 3, I want 7 fries, so plus 7. After that, I have nothing left to combine, because I can't put together 7 hamburgers and 7 fries to make 14 of anything. It's just 7 hamburgers and then 7 fries. That's it. We're finished. So next problem, I won't assign these type of things to them. I'm just going to talk about them as different things. So we have X's here, and then X's back here. This guy looks like X's, but he is not. He's X squareds. Think about it this way. If I'm sitting there with a hamburger, and my brother is sitting next to me with a jumbo mac whatever with bacon on it, with my little hamburger, I know it is not the same as his big friggin' jumbo mac thing with bacon on it. This is different than the x. So, x's are one of my terms I can combine. Moving on here, I have y's. There's y's here, and there are y's here. Nothing else has y's, so I won't combine them. My next type of term is numbers. I have numbers there, and then there are no other numbers. Lastly, I have x squareds back here, which are different than everything else.
Miss Patty Lane, would you please dial 5420? Patty Lane, 5420, thank you.
That was annoying. So, now I can combine the things that are alike. We have two x's, and then a third x here. Remember, there's only one of them there because it doesn't have any coefficient in front. Two x's and another x gives us three x's. The next type of term we have is the y's. 6 y's and then 8 more y's add up for a total of 14 y's. I've done my x's here and I've done my y's here. The next thing I have is this 12. There are no other numbers that don't have a label on them. So this 12 stays the same, it's all alone, plus 12. Lastly, I have my x's, I have my y's, I have my 12. This x squared is the only thing that's left, and it has no one to go with, so it still is just x squared. If I wanted to tell how many of these there are, since there's no coefficient again, it is 1x squared. But I don't have to write that 1. I can look here and say there are no other like terms, so I'm finished. All of my like terms have been combined. So we're moving on from combined like terms. We're going into distributive property here. In order to talk to about distributive property, I would like to talk about this scenario. When ordering at a drive-thru, my wife wants 2 hamburgers, fries, and jalapeno poppers. I want 2 hamburgers, fries, and jalapeno poppers. Also, our friend who's with us in the car wants 2 hamburgers, fries, and jalapeno poppers. So we could write this out. My wife wants 2 hamburgers, 2H. Also, my wife wants fries, F, and she wants jalapeno poppers, J. This is all of the things that my wife wants, her order, plus the things that I want, which is 2 hamburgers, I want fries, and I want jalapeno poppers. These are all the things that I want. Also, we have our friend with us in the car who wants 2 hamburgers, fries, and jalapeno poppers. I could go ahead and combine these like terms. I could say we have 2 hamburgers, 2 hamburgers, and 2 hamburgers for a total of 6 hamburgers. Fries, fries, and fries for a total of 3 fries. Jalapeno poppers, and jalapeno poppers for a total of 3 jalapeno poppers. And I could add them together this way. Or I could notice this is an order containing 2 hamburgers, fries, and jalapeno poppers. We have another order that is exactly the same things, and a third order with exactly the same things. So I could say we have 2 hamburgers, fries, and jalapeno poppers comprise one order. We have 3 orders that are identical, so I want 3 of those orders. Now, if I have 3 entire orders of these things, I have to know 3 orders of 2 hamburgers make for 6 hamburgers. 3 orders of one fry make 3 fries. And 3 orders of jalapenos make for 3 jalapeno poppers. This is all the things that I want to ask the attendant for. And I could think of it as combining my like terms when I've written it out like this. Or I could think of it as 3 orders that are all identical. So I simply multiply 3 times 2 makes 6. 3 times 1 French fry makes 3 French fries. And 3 times 1 jalapeno popper makes 3 jalapeno poppers. This is called the distributive property because you're literally taking this 3, because I want 3 entire orders, and distributing it to each piece of the things inside the parentheses, the things that comprise one order. So, examples of the distributive property. I can think of this is not just 2 x's. It is 2 of this entire order. So, when I multiply that 2 in, I get 2 times x makes 2x, and 2 times 3 makes 6. Then I can check myself. Did I get 2 of this entire order, or did I screw it up and only multiply 1 piece? Well, I multiplied 2 times everything. My distributive property holds. I want 6 orders of these things. So, 6 x's makes 6x, and 6 negative 2's makes for negative 12. Again, this is 6 entire orders, so I have to multiply both pieces. Here's where I have to get away from thinking about orders, because what does a negative order look like? I'm not quite sure. So instead of that, I have to think of things here in terms of pure mathematics. Well, we can all see when we multiplied this 2 in, it multiplied both individual pieces. So when I multiply this in, this negative will multiply both individual pieces. So, negative x, well, a negative times a positive makes a negative, and then it's x. If you don't like that and you want a concrete number to put here, since there isn't a number, it is an invisible 1. Then I have negative times positive makes negative, 1 times x makes x. Then I have to multiply also back here. Negative times positive makes negative, 1 times 1 makes 1. And that is finished. I should have boxed my answer up here as well. Oh, and down here as well. Lastly, down here, I'm looking at, again, this is an invisible negative 1. Negative times negative makes a positive, so I could write that plus, or I could omit it. And then 1 times y, the invisible 1, times y makes y. Negative times positive makes negative. The invisible 1 times 3 makes 3. And so y minus 3 is what we get finally. Here are an additional 4 problems that we would like you to attempt for homework and bring tomorrow. This 4th problem is challenging because it involves both distribution and then combining like terms. So make sure you take several steps to complete this problem, and make sure all of your like terms are combined in the very end. Best of luck. See you tomorrow in class.